And one, they give you questions. So they want you to copy from the topographic and the orthophoto map while you're answering the question. In other words, it's fun. It's easy marks. Easy for you and easy for everyone. So you must know how to work with maps and how to read those maps. Now that's map orientation is very important in this aspect. Know how to work with them, know how to read them. First of all, I would like to ask you guys, do you know the difference between topographic and orthophoto map? Topographic, it shows that physical and human features, normally in color. The scale is 1 to 50,000, always in South Africa. And the other orthophoto, that is always in black and white. The scale is 1 to 10,000. Call it orthophoto map. In this case, before we even go any further, we must know the map work symbols, the map symbols. What are the symbols? In other words, we are going to start by orienting the map, just to know what is on the map before we even look into the depth of what you are supposed to cover. So under that line, if you get to know some of the symbols on the map, then it will become easy. Okay, map symbols, how are these symbols, or how are the following represented on the map? Number one, when you look at this part here, this shows the national road. Okay, this shows the row of trees. This one is showing the cemetery. You understand? So we are going to look at all these ones: the wind pump, the railway line, the water, the power line, and so on, and reserve, and so on and so forth. So we want to see how they look like in reality. We start with that one. The first one that you see is the national freeway. National freeway, it looks like this. I think everyone has seen this in South Africa. It looks like this. But now, how do we see it on the map? On the map, it is represented by this symbol, a blue line, and the end there, which shows that it's a national freeway. Then we go and look at a benchmark. Benchmark is also indicated. This is how it looks like in real life. But this is what it is showing on the map. Normally, benchmark is showing the height of the road on a map. So you will see that it is located at this height here. Okay. Then we go ahead, we look at that one. I think you know this. You can see that these are railway lines. Okay. So if this is a railway line or a railway, these are this is where the train passes. On a map, it is represented like this. And therefore, this on this box here is always a name, the STA. STA stands for a station. So this is the railway line and this is the station. So this is how it is in reality. This is how it is represented on a map. Okay. Somewhere there, you can see a bridge. See that we have a river flowing underneath. We have a road on top. And therefore, this one is a bridge. In other words, it is bridging this so that people can cross from this way to this way without crossing through the river. So it's a bridge. On top there is a bridge. How does it look on the map? On the map, we are going to have this symbol. And therefore, when you see this, it's a bridge. It's a bridge. Okay. We move ahead. We have this one here. I think you have seen it somewhere. And we have this one here. So that one on top is what we call a water tower. It's basically for storing water. It's a water tower. So on the map is represented like this. And in reality, it looks like this. Somewhere there, we have what we call a wind pump. You have seen there that here is a farm. And here are animals. They need water to drink. So when this wind blows these spades here, it pumps water from underground for these animals or for use. Therefore, we refer to it as a wind pump. And that is how it looks in reality. Somewhere there, we have a communication tower. A communication tower, you have seen this, I think also somewhere else. It has got these other things there on top, and therefore it's used for communication. On a map, it is indicated like that. And on the other line, we have the trigonometrical station. And we say that the trigonometrical station is also one indicator of a height on a map. And as you're indicating the height on the map, in reality, it looks like this. But now, on the map, it is represented by a triangle. There's a number on top and there is a number at the bottom. Normally, This number with the decimal point is the one that shows the height of that trigonomical station. The number on top is showing the number of the trigonomical station. Maybe in this case, this one, we can say it's number 72. But 72 is not the height. The height is 887.9. So that is what we refer to as a trigonometrical station. It's basically an indicator of height on a map. Okay. We also have this. I think you have seen this, guys. In this case, you are seeing a line of trees that are planted alongside the road. There is a road somewhere there, and you are seeing trees, and there is a car actually coming there from that far. So this line here of trees, what will it be called? A second there, a pause. What do you think it will be called? I can see now people are coming up with answers. Yeah, it's a law of trees. Just like you see on the map, it can be these trees are in line. These are the trees in line, and therefore it's a row of trees. What do they do? Normally, when you see them planted along the road like this, it can be for isostatic look, or to make the place look beautiful, or maybe the place is experiencing very strong winds, and therefore the trees act as wind breakers, so that the cars can pass easily without being disturbed by the strong winds as the trees break them. But these are row of trees. And somewhere here, there is a farm. You can see the cultivated land that has got maize on it. And therefore, on the map is represented like this. Next, you see symbols. And this is how it looks in reality. We go down here. You can see power line here. We have very heavy lines here. And these lines are basically taking heavy current to maybe industrialized areas or areas that use a lot of power. And what would that be? That is what we refer to as a power line, basically taking electricity to areas where it is supposed to be used. On the map, it will be indicated like this. But I think this one is obvious to everyone. Okay, this one is obvious. I think, don't say that this is the place where they sell tombstones. No, you can say tombstones are laid on the ground. There are trees somewhere there, and there are too many. Therefore, it's a cemetery. And you can see on the map is represented like this with a cross. Okay, so please, our fellow Muslims, don't be angry because we are not using a moon and a star. We're using a cross in a way of representing a tombstone. Somewhere there we have other aspects. For example, we have seen those ones, cemetery, and so on and so forth. So we are supposed to go ahead. And there actually here is just representing the types of farming. Okay. Besides this cemetery, but these are just types of farming. So we shall look at that when you reach that side of farming. And there is also another symbol there. I think when you look at that, you can see that there are a lot of people there, and there is this building here. Maybe these people are coming from worshiping. That looks like a church. Okay, so what will it be? It's a worship place. And on the map is represented with that letter K with a dot, and that is what it shows. In reality, this is what it is represented on the map. Somewhere here we have a dam, and therefore there is a wall there. There is water there. What will it be? We call it a dam wall. This is a wall of the dam, in that water just passes through and goes to its destination without any disturbances. We shall look at more on how a dam and a dam wall shows or how it represents the direction of the river. But the dam wall here is this dark line. This one is a dam wall. So this one here is the whole dam where water will be. Okay. All right. We continue to another one. Somewhere here we have what we call the coastal rocks. We have the coastal area with a lot with water there, and you can see the rocks, the pavement of rocks that are really protruding out here. So this is what we call the coastal rocks, and that is how it looks like in reality. This is how it appears on a map. Okay. Hope learners, you are moving at the same pace and you understand. We are trying to orient a map. You know, if you understand the symbols of a map, you can easily interpret it. So they give it to you. You look at a symbol like this, and then you know, oh, I saw it. It's like that. Or you look at a symbol like this, you can remember, oh, I saw it there. Okay. We move ahead, and you have what you call international boundary. Somewhere here, it is saying Pefuri border control. In other words, this is a border area. People crossing from that direction to this direction, from this way to the other side. They are crossing countries. And they say, welcome to South Africa, meaning that when you cross this border, you are going to South Africa. So in that case, this is how it is indicated, a line and dots there. And therefore, that is international boundary. International, that's it is separating countries. Somewhere there, we've got other symbols. A store. Store, let me say, these are the stores that we have. These ones are stores. And therefore, it is represented by this symbol on the map. Alongside that, we have a reservoir. A reservoir, this is where they store water that can be used in the later stage, or maybe when it is dry and so on and so forth. So it's R there with a dot, or is in blue color. So on a topographic map, therefore it is a reservoir. Down there we have a built-up area. In other words, you can see a lot of structures that are built up, well structured in this area. So you can see blocks of land here that are indicated on the map. So in this case on the map, it will appear like this. In reality, it will appear like this. Those are built-up areas. Somewhere here we have an excavation. Maybe mining took place here, and it looks like this on the map, and this is an excavation. Okay. Hope I'm not so speedy, learners, and we're moving at the same pace, and I think we understand each other. Okay. We proceed, learners, and somewhere there we have another symbol, a river that is having water, that a river with water there. And this river here, this is how it shows on the map. You can see that it is a continuous blue line, meaning that this river here, if you see it continuous with a blue line like this, it's a perennial river or a permanent river. Remember, in your geomorphology, you know the definition of a permanent river. These are rivers that flow throughout the year. They have the water, the riverbed is always below the water table during the rainy season and the dry season. Therefore, in reality, you will see a permanent river like that. Okay, this is how it looks, but on the map, this symbol shows a permanent river. So long as you see a line like this, not broken, a line that is continuously blue drawn. What about a non-perennial, the river that is seasonal, that only flows after heavy rainfall, meaning that the water table is above the riverbed only during the rainy season, is below the riverbed only during the rainy season. Okay, so it can easily have access to water after it has rained. How is it shown on a map? On a map, you're going to look at something like this. Dotted lines, blue dotted lines. You can see they are broken lines, blue but broken. I want you to notice the difference. You see here and here, it's totally different. This one is continuous, meaning that this one, the river flows throughout the year. This one, the river only flows after or during the rainy season or the wet season. So at times you have seen, you have been asked questions like, what evidence on the map suggests that this area is experiencing seasonal rainfall? So, and you see something like this, just know this area is experiencing seasonal rainfall because the rivers themselves, the symbols of the river are broken. So it rains only during the rainy season. Okay, it flows during that time. We have another symbol here that is a protected area. You will have to look at it on the map. It looks like this, a green line. Okay, continuous line like that, and therefore this area here is protected. Like for example, Kabakoloburg restricted zone. Okay, in this case, it shows that this area is protected, and this area can be used for tourism, or it's a protected. In other words, it's gazetted. You don't just cross. Before you go there, you have to get permission. So that is a protected area. Somewhere there we have what you call a lighthouse and marine stars. It's normally where we have water bodies. So these are like towers that you see. It's not necessarily communication towers, but you can see it at the coast there. And then it is indicated with this red star on the map. And that is how it looks like. Okay. So learners, we have covered a lot of map orientation. That is basically the map. Now we need to embark on the skills. So the moment you orient the map and you get to understand it fully, that this is what it means, this is what this one means, this is where the map, this is symbol here shows the man-made features, this symbol here shows natural features. Just like from what I told you, that we have been looking at this from grade 7 or grade 9, 8 until grade 12. But now we need to apply some skills in order to understand map work very well. Okay. And in these skills, you get to know how to locate areas. Which skill do I use when I'm locating areas? Cardinal points. How do I use cardinal points? How do I calculate the true bearing? How do I? Now that we are getting the skills. As we continue, we are going to find out how we use these skills. First thing first is the direction. Now that's what is the direction of area A from area B? What is the direction of area C from area D? Now that's when you're looking at direction, there are two aspects here that we must notice. That when you look at direction is to, and number 2 is from. For instance, what is the direction of A from B? Or what is the direction of A from? In other words, if we don't use to, we use of, but normally there is from. And in this case, when you are given direction, the first thing that you must look for is the from word. This one. That what is the direction of A from B? In other words, we start from B. Let me use an example here that this is A and this is B. And they say what is the direction of A from B? We are moving from A to go to what? We are moving from B to go to A. Therefore, we start from A, B. And at B, that is where we draw our compass. This is where we draw our cardinal points. So when you talk about direction, and when you draw cardinal points, we must know that direction is basically the two words that are important are to, of, or from. And when you look at those words, we must know that the cardinal point or the direction has the following. We have N, E, S, W. Okay, so that means never, in simple terms, never, ever smoke weed. Never, ever smoke weed. Now, never, ever smoke weed. This one is the north. This one is the east. This one is the south. This one is the west. Okay. So having understood that, never ever smoke, we move clockwise like this. Don't move anti-clockwise. We move clockwise like a clock, like a wristwatch. So we know that the direction is either north, east, south, west. We have others, like what? A line that is drawn halfway, crossing north and east is northeast. And somewhere there it's crossing south and west, therefore southwest. Okay. Also, we have another one here. And therefore, this one normally is northwest. And this one is southeast. There are 16. In other words, if I draw 16, this is what I need to know. If I draw 16, this is what you need to know. 16. You do like this. North, east, south, west. Okay, and we cross there, You also cross, sorry, cross here. You say, I'm struggling with my pen. Northeast, southwest, northwest, southeast. So somewhere here, you can say north, northeast, south, southwest. So somewhere here, you can add east, south, east. Somewhere here we say west, northwest. Then you can do another one here to say south, southeast. And here you say north, northwest. You can draw others in between. Others, they should be 16. Okay. So we are looking at the line of latitude and lines of longitude. I said the latitudes are drawn, they are drawn like this. Okay. They're drawn like that. They're drawn like that. You can see that they are horizontally running from west to east, but increasing the south. Let me say 29 degrees. Then this one is 30 degrees. This one is 81 degrees. You can see that it is increasing to the south. So those lines that are increasing to the south are known as the latitude lines. And normally, when we are doing map work or when you are doing map reading, we start with the line of latitude horizontally. In most cases, map work is fun, like I told you, is what we do every day in our real lives. Take an example. Normally, I would like to just remind you through your lifetime. When you were a baby, you started by crawling on the ground. And then later, you start walking one step at a time, and maybe your guardian, your mom, your dad claps hands because they are seeing you putting a step ahead. But before you even start putting a step ahead, you hold yourself on tables, chairs, walls. In other words, you started crawling on the ground, which is a way of representing or a way of respecting the line of latitude. Then later on, you start getting vertically up, hold yourself on the wall, and then you walk. So you start with the latitude before you go to the longitude. Another scenario, when you go for maybe athletics, or maybe you go to any field event, or you go to the field to do maybe athletics, they tell you get on your marks. At least if you can't go, you put your knee either on the ground or you hold your knee if it's a long distance. Why do you do so? It's not fun. It's because they're trying to respect the law. The law is that latitude should come first. That's why you go to the ground. Then get on your marks, get set, then you get up. Then you go. In other words, they are respecting the latitude line before they go the longitude line. In the same scenario, when you go to the airport, before the plane takes over, they have to push it on the ground. Okay, they push it on the ground for a distance to gain momentum before it starts landing up, before it starts taking up until it goes into space. So it starts from the ground to respect the line of latitude before it goes the line of longitude. So the longitude is drawn like this, like this, like this, like this. Can you see these learners? Let me say this is also 29, 30, 31, 32, 33 degrees. You see, in this case, what does that mean? That this one is increasing to this other side. Okay? This one is increasing to this side. And this one is increasing to this side. In other words, this one is increasing to the east. This one is increasing to the south. Therefore, the section that I'm drawing is coming from the southern part on the eastern side. Okay? That's why when you're writing coordinates, at the end of every coordinate, you put south and you put east. In this case, we start with the latitude and we go to the longitude. The latitude, see that it is increasing to the south. So how many minutes? we say it is 26 degrees, 45 minutes. In other words, this symbol here for the degree, this symbol here is for the minute, and the symbol for seconds is when they are two. I could draw them two like that. Okay. And in this case, it's 26 degrees, 45 minutes. Then what will this one be? The same degree has not changed because it's still the same minute. Therefore, it is 26 degrees, 46 minutes south, because we are going south. But don't forget that from here to here is 1 minute. Okay. And 1 minute has got 60 seconds. So it simply means that from 45 to 60, we have 60 seconds in between here. Therefore, if my feature is this, it's going to be 26 degrees, 45 minutes, 30 seconds if it's halfway. And therefore, that is how we calculate, or that is how we find the coordinates. And we put south at the end. That's why you see on every coordinate you're finding, the always S at the end. Okay. I want to see the longitude. The longitude is increasing to the east. And you see that from 29 degrees, 0 seconds. And then we proceed to 0 minute, and then we proceed to 1 minute. So from 0 to 1, how many minutes are there? It's only 1 minute. But this 1 minute has got 60 what? 6 seconds. However, 1 degree has got 60 minutes. 1 degree has 60 minutes, but 1 minute has 60 seconds. And then that one goes to the east. Therefore, if you are to record this, it's going to be 26 minutes. Let me say we are looking at this feature here, which is 157. Okay, 157. 157 is going to be 26 minutes, 46 seconds south. You put a comma, then longitude, 29 degrees and 01 minute east. And in this case, these are only degree and minutes. And normally, don't forget that it's also seconds. I'll teach you how to calculate seconds when you proceed with these online classes or when you proceed with MapWork. Okay, so that is how we find coordinate, and therefore the number is that. I want us to see this. There is another spot height there. There is another trigonometrical station there, that triangle. How do we count? We said we start with the latitude. Consider that the longitude is not there. So what will you say? The latitude is going to be 26 degrees. What is the minute we're starting with? The minute is 41 minutes. Okay. And then it is somewhere there where it is lying. Don't forget that we said 1 minute is equivalent to 60 seconds, and seconds are represented by these two symbols here. So from 45 to 60, we have from 45 to 60, we have from 45 to 46, we have 1 minute, but 1 minute is also equivalent to 60 seconds. Therefore, if we were to divide this section, you can use what we call the estimation method, or you can do accurate calculations. Let's first use estimation. Estimation means that from here to here is 1 minute, and 1 minute is equivalent to 60 seconds. Therefore, half of this in terms of seconds is going to be 30. Therefore, here, from here, it cuts half. Therefore, 30 here, 30 here to make it 60. And you see 30 minutes. But half of 30 is what? 15. Therefore, if this is 45 minutes, 0 seconds, 15 seconds, 30 seconds, 45 seconds, and then 46 minutes, you can see that, learners. So in that case, we say that if I divide this section into other two sections, into other sections each, it will mean that if this is 45, 0 seconds, this is 15. Okay? This is 15. And you proceed until when you meet the last one at the bottom. We're going to say, if we were to use it in terms of tens, this is going to be 10, okay? 10, 20, 30, 40, 50, 60. Now, this one is in tens. But if you don't use it in tens, you can say this is 45, 0 seconds. Half of 30 is 15. Therefore, 15 is going to be somewhere here. But before you reach 15, this is where our symbol is. Therefore, it becomes 12. Somewhere there, 12 or 13 there. So in that case, it's going to be 26 degree, 45 minutes, 12 seconds south. For that means that one is only the line of latitude. Okay, so we must go the line of longitude. The line of longitude, what do we have? We go and cut there where the symbol is, and then we get to see that it is sitting somewhere there. But don't forget that from 0 minute to 1 minute, there is 1 minute in between there, but 1 minute is equivalent to 60 seconds. Therefore, we do what we call estimation. We divide our section into different sections. So we shall use the tens. In this case, we are using the tens. So meaning that 10, 20, 30, 40, 50, 60. Okay, meaning that from here is 0. So the 0 is here. 10, 20, 30 is here. 40, 50, 60 is here. And remember, when it reaches 60, the number changes. So it was 0 minute, 10 seconds, 0 minute, 20 seconds, 0 minute, 30 seconds, 0 minute, 40 seconds, 0 minute, 50 seconds. Instead of saying 60, we say 1 minute. And then this is 1 minute, 0 seconds. Then you can proceed like that, like that. Where the feature is cutting is not exactly sitting at 40. It is sitting at around 41. Okay, therefore, it's going to be 29 degrees, 00 minutes, because we have not yet moved it 1 minute. So it's still 00 minute, but 41 seconds east. And I remember I told you that when you're writing coordinates, you write them in 6 places. So 1, 2, 3, 4, 5, 6, 7. Southeast. The moment you see south, we said the line of latitude increases southwards or northwards. But since we are dealing with the map from southern hemisphere, we put south. But when you move to the west, to the east, in terms of the longitude, we put east at the end. Therefore, we get a proper calculation for coordinates. Okay, so learners, we find this. This is how we find coordinates. You will be given in exams, always you will find that number. It's always 2 marks. Why 2 marks? Because they will give you a place and they want you to calculate or to find the coordinates, and those are 2 marks. In this case, we have used 2 examples. We started with a grid square, and the grid square is this one. It's a square 4, and then we go to the 6 places. The 6 places is giving us the coordinates. So in this case, if you are to find this the coordinates for this place here, 157. So it's going to be 26 0 minutes, 26 degrees, 46 minutes, 00 seconds south. The same way, 29 minutes, 01, 29 degrees, 01 minutes, 00 seconds east. So that will be 6 places. Okay, because this one is exactly sitting at a 46 minute. So it's 46 minutes, but the seconds have not changed. So it is 0 seconds, the same way here. So that is how we find coordinates. Hope you are getting me, learners. Hope you are moving at the same pace. I don't want to leave you behind and then you struggle finding these things. Like I told you that when we are doing map work, you must make it fun. Make it fun to even yourself. Get used to it. Practice. Ask your teachers to give you the maps so that you can practice every day. So you will go listen to this audio, see what we are doing. You go to the map and find any place and try it yourself. Don't forget, we start with the line of latitude. Then from the line of latitude, you go the line of longitude. What are the lines of latitudes? The line of latitudes are drawn horizontally, increasing southwards. The line of longitude are drawn vertically, increasing eastwards or westward. So in any case, you'll find out what will be given to you on the map. Okay, that is another skill. So today we have covered orientation of the map, we have covered direction, and we have covered coordinates. Okay, so it is 3 marks, guys. Imagine you find those 2 numbers or 4 numbers and they're just asking, check the man-made feature that is found in block A5. Okay, a man-made feature that is in block A5. you know that something that is man-made has only intervention of man, not godly, like house, like a road. So you look for something that is man-made. And if they ask for something that is natural, that means you look for something that is maybe set up by God. Okay. Now, another skill that I want to impart in you learners is the skill of what we call map reference. Map reference. In other words, sometimes it refers to as the map code. The map code has got this, you normally see it on top of the map, I think on the top of the left-hand corner of the map. And then you find out that there is always a number, 4 numbers, this, and this, and the letters. This is what we call alpha, this is what we call map code. Okay, map code, let me say they refer you to the map and you'll find something like this. What does this mean, learners? It's not something very difficult. Let's see what it means. You first of all look at the numbers. There are 4 numbers. Okay. So what you do, you first divide these numbers into 2. What I mean dividing is not like using calculator and divide by any number, just to divide to 2. 1, 2, 2 here, 2 here. So the first 2 that you have is the line of latitude. Remember, I told you that we start with the line of latitude in whatsoever case. We start with the line of latitude. It's the law, it's the principle. We start with the line of latitude. So 33 is the line of latitude. So in this case, remember, we are dealing with the maps in the southern hemisphere. And therefore, our 33 will be here. So 33, and this one will be 34. And when you go down, you'll have 36, so on and so forth. And 22 is the line of longitude. Let's see. Do you say that it is 33 degrees, 00 minute? And you say that. So this line here is the latitude. Why the latitude? Because it is drawn horizontally, increasing southerly, meaning that this is the one is the latitude 33. This one is the latitude 34. Then this one is the longitude, because for it, it is drawn vertically, increasing to the east. Which number do we have here? Is a 22. So you put 22 degrees, 00 minutes here. So the next one will be a 23, meaning that even if I don't close here and I look at this, in other words, this is wherever it is ending, it will form a square when you close it. So what does that mean? It gives us what we call a grid square. Okay, a grid square. Grid square has got 33 degrees, which is the latitude line. So from 33 you go to 34. Then from there we have another line of longitude, which is a 23 degrees. So when they cut into here, when you meet another line and another line, they form a square. So this box here is the 33, 22 degrees. Therefore, the 33 is the latitude, 22 is the longitude. Hope we're together, learners. Then from there, we have what we call a C and A. These are letters. What does that mean? C is the big block, meaning that this grid square is going to be divided into 4 sections at first. The 4 sections include, this is my division. So it is A, B, C, and D. So we refer to these ones as big blocks of this grid square of the latitude 33 and 22 longitude. Therefore, it's A, B, C, and D. So A is big block A. There is B, which is big block B, big block C, big block D. But according to this, it's given 33 degrees, 22 degrees, CA. So the big block we have is C. We don't look here, we don't look here, we don't look at D, we don't look at C. So within here is where we have C. So this is where we shall have this coordinate, map code. But alongside that, we have another A. A stands for a small block. Within that big block, we can then further divide it into 4 again sections. That is like this. Therefore, it becomes A, B, C, D. Therefore, when we are naming it, we say CA. That's why you see it is 3322 CA. So CA. So this 3322 is in this block here, this section here. In this block C, but this section A. So it is CA, it is CB, it is CC, it is CD. So this one will be DA, DB, DC, DA, DD. Then this one will be AA, AB, AD, AC. This one will be AB, AB, this one will be AB, BB, BC, BD. Now that's B is the big block. So we start with B before we go to the small block. Or the small block is a subsection of this big block B. So those are what we refer to coordinates. Therefore, learners, when you are given these coordinates, please understand 33, 22, CA is latitude 33, longitude 22, big block CA. There are always questions that are asked there. They are always so easy to answer. But learners get so much scared of those questions. But those are the things where I was talking about. You can see there that it is let me just go back a little bit. You see here, which one is the intersection, point of intersection is this. So we put a 33 and a 22. So that point here is the grid square that I was talking about. So it is CA section. So that is where this coordinate is coming from. We go to this other side. We also do the same. What are we going to have? This is 22. But if this is 23 and this one is 22, what will this one be? So this one will be 21. Okay. But this one is still the same line, which is 33. And this one is still the same line, which is 34. Therefore, within this block also we divide it into 4 sections, A, B, C, D. So big block A, big block B, big block C. Okay, we go ahead and then divide it. Okay, go ahead and then divide it. That if this is A, so you put here the division is going to be A, B, C, just like you did here, A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D. And therefore, this one is going to be A, B, AD, AC, like that. Okay, hope you understand, learners. Let me hope I'm not leaving anyone behind. I want to use to come up with one example. This one example, let me say it is 28, 21, D, A. What do we do? We say 28 is a what? Is a line of latitude. So we can start by drawing the line of latitude. We say latitude are drawn horizontally. So if this is 28, this is 28, right? So when you're going down, it will be 29, 30, and so on. So we divide again here. So this is going to be 21. So the moment you draw the second one here, that means this is going to be 22. So the what we are dealing with is this section here. Is this section here. So this section here, we can divide it into 4. So that we get A, B, C, D. Okay. Sorry. This is C, and this is D. According to this, they are saying it's big block of the river is the C. Therefore, this river is moving eastward. Okay. Number 2 is we use the contour lines. Let's see here. In this case, when you look at this area, we have this contour line which is 380, 360, 340, 320. What does that mean? 80 is above. 380 is above than 320. So because 380 is at a higher elevation, 320 is low. So this river is flowing from a higher elevation to a lower elevation. You will never find a river that is climbing a mountain. It will not be there, my dear learners. Don't make that mistake. A river is flowing from a higher elevated area to the low-lying area. Therefore, in this diagram, or in this case, The elevated area here is this 380. Height is higher than 20. So it is flowing from this way. That's why you see my arrow is pointing downwards. So we use contour lines. Okay. The second evidence that we use is besides contour line looking at them, we can look at the way they are bending. In other words, contour lines bend upstream. In this case, if the contour lines are bending like this, you see this V. I want you to look at the V. Just know that this river is flowing to that direction. Because this way is low, this way is high. It always bends towards where it is high. Okay, so we use the nature of the contour. That's how they are drawn on a map. We use another one is the dam wall. My good learners, dam wall shows the downstream. If a river, imagine this river was entering from this other side, and here we have a dam wall. The force that the river comes with from this way, it will break the dam wall. Therefore, that's why you see the river is always entering from the opposite direction where the dam wall is. In this case, the dam wall is here, therefore the river is coming from this way, flowing the other direction. Why? Because when it enters here, by the time it reaches the dam wall, it has come down, it has reduced the pressure and the speed. So it won't affect the dam wall to break. So to avoid breaking of the dam wall and serious wastages, what we do, we ensure that the dam wall is this way, the river is flowing from behind the dam wall. That's what we mean by downstream. So that's why this river is going this way, because the dam wall is here. It cannot enter from this way because it will break the dam wall. Okay, number 4 is the angle at which tributaries are joining the main river. Tributaries are joining the main river at acute angles, less than 60 degrees. You can see here, like this, it forming this V. Okay, that means this river is going into that direction. So the moment you see the streams joining at this acute angle, it's not the river are flowing into that direction. So that is how to understand the direction of the river. Let's see in reality on the map, how would it be? You can see, learners, that here we have a sea. This is the coastline, rock outcrop. Okay, rock outcrop, it's here. You see these rocks, this is the sea. And somewhere here, you can see the mouth. What does that mean? That the moment you see this mouth here, this river is flowing towards the sea. So this river is coming in there. Okay, we have another aspect that we can refer to. Look at this. And you see the way the contour lines are bending towards the hill. Because they're bending towards the hill, this river is flowing, coming down. See that? So the river is flowing downwards because the contour lines are bending towards the hill. Number 2, and that is how you see it on the map. You will see that this is a river here that is flowing on this orthophoto map, and therefore it is flowing towards that direction, going up like so. Okay, another thing is in terms of flows from high to low, look at this. Can you see that? I want you to look at this. We have different spot heights here. We have this one which is 309. We have this one which is 299. We have this one which is 286. Of the 3, which one is bigger? This one is bigger. And because it is bigger, that means this side is higher, this side is lower. Therefore, this river is flowing from this way to that side. Let's see. You see here, that is 309, 302, 299, and then 296. So the river is flowing in that direction by looking at the readings of this contour lines or the spot height, sorry. We also look at the angle. We said it joins at acute angles. Can you see here? Acute angle, that means flows in this direction, flows in the direction, then it goes this way, flows in the, it goes this way. This one joins here, come this way, this one this way, like that. Those are acute angles. So those acute angles are busy telling us which direction the river is flowing to. And this is that these are here bit by bit, bit by bit. Then we shall apply them. Every topic we cover. Remember, in geography, every topic we cover, we have to apply map work. Every topic we cover, you have to apply map work. So the more you do map work, the more we apply to the theory. The more you do theory, the more you apply. And then you will not find any trouble in exams. Like I told you, that map work, make it fun to yourself. Practice every day. where you get a chance. When you do a topic, ask a teacher so that you can do practice. Okay. Thank you so much. See you next time. Bye-bye. Being shared with you. And therefore, I looked at a lot of things last time, but still, I want to look at more. And this will help us to understand the concepts in map work, to understand everything in map work, that when you're writing, it won't be stressing you. Okay, so in this session, I want us to focus on basically map calculations. Last time, our focus was on map interpretations, how to identify features, how to know the man-made and the physical features. In other words, we did the map orientation and map interpretation. Okay, I remember very well what we explained regarding the scale, the physical features, the man-made features, and so on and so forth, map code and everything. So we did that last time. So today, I want our focus to be on basically calculations. Okay. So dear learners, girls and boys, what you see on your screen is talking about what you need to know regarding calculations. When you're doing calculations, it is important to follow all the steps in order to get all the marks. In most cases, I see learners jumping steps, and when I'm marking, I don't mark the answer because I don't know where the answer is coming from. So in this case, I would like you to know that when you are doing these calculations, you make sure that you follow each and every step while doing your calculations. That's number one. Number two, that on those calculations, on the calculations you're doing, you make sure that you put all the units necessary for you to proceed with your calculations. For example, if you have measured on a ruler, and now you have measured this line here, and you have used the centimeters, okay? It's not a problem when you're writing your units. Let me say you have measured 2 centimeters, therefore you write 2 centimeters. There's no problem. If you have measured 1, you write 1 to show the units of measurements. It even becomes easier for you when you are doing conversions because you know which units you are changing from to which units. Okay, so it is very important for us to know the units in which we are doing the measurements on the map. That's one thing. The second thing is that when you're doing your calculations, you also need to be sure of the kind of map you are using. Take an example. When you read the question and the question says the topographic map, please straight run to the topographic map. If the question says orthophoto map, quickly run to the orthophoto map. Because what you must understand, learners, that these maps have got different scales. And these different scales help us to understand the units in which we are converting the aspects into. Therefore, we need to make sure that we know the units of measurements and the kind of map you're using. Okay. The second thing is that the relevancy of the different calculations. This makes understanding of the calculations easier. For example, gradients. If you're dealing with gradient, what do you need to know? When you're dealing with gradient, you must know that the gradient simply means how steep or how gentle the slope appears. So under that case, you know that when you're calculating the gradient, you need to understand that I need to know how steep or how gentle the gradient is. Remember, when you're dealing with the gradient, we know that the smaller the number, the steeper the gradient. The bigger the number, the gentler the gradient. So by you understanding all those concepts, knowing the value, knowing why you're calculating, then it becomes easier for you to be on track. You will not lose track at all. Okay. Now, scales of different maps and the conversion. I think this is what I've just talked about in the previous bullet. I said that you must know the different maps, and each map has its own scale. Take an example. you're dealing with the topographic map. What is the scale? The scale is 1 to 50,000. And if it's 1 to 50,000, you must understand that if I'm changing from centimeters to kilometer, I use 0.5. Why 0.5? Because the map is a topographic map. And the topographic map, 1 centimeter on the map represents 50,000 centimeters on the ground. So in terms of kilometers, it's going to be 0.5. So under that line, you get to understand that regarding the aspects of a topographic map and the orthophoto map, we need to understand which scale is being used. Okay. All right. So if you look at the orthophoto map has got 1 to 10,000, which is the scale. So if it's 1 to 10,000 as the scale, that means 1 centimeter on the map represents 0.1 kilometer on the ground. That is in terms of kilometers. Okay. But the same way, 1 centimeter on the map represents 100 meters on the ground in actual reality. Okay. So meaning to say that the moment you familiar yourself with which kind of map am I using, how important is this map, or what is the scale of this map, it makes it easier for you to understand what you are now dealing with. Okay. Maps are always smaller than the area of the ground they represent. This is obvious, because if the map was at the actual, was having the actual length, or the actual length, the way it is in the ground, it simply means you are not going to be in a position to represent it on the map, on the paper. So it is very important to understand that a scale is used to ensure that the maps can fit on the paper. It is from that background that you know that if there is no scale, or if we are not having scales, it was going to be very difficult for us to represent the distance on the ground and to show the relationship with it on the paper. Okay, sorry. Now, there are 3 ways we're using these scales, or there are different types of scales. I think I mentioned about this last time. Representative scale, fractional, or ratio scale. Actually, when we talk about fraction, you know that the ratio is existing in a fraction format. And then when you talk about the ratio scale, it simply means it's a ratio format. For example, 1 to 50,000 is ratio. That means 1 centimeter on the map, excuse me, 1 centimeter on the map represents 50,000 centimeters on the ground. What you must note with the ratio scale, ratio scales normally will have, in most cases, they represent the same units. For example, centimeter on the map, centimeter on the ground. But it's not a must. We can also say 1 centimeter on the map representing 0.1 kilometer or 0.5 kilometer on the ground. Therefore, that is the ratio. But you know very well that we can convert the ratio to fraction mathematically. When you're converting the ratio to fraction, it simply means if it is 1 centimeter, if it is 1 centimeter representing 50,000, how will we represent this in a fraction? We just have to have 1 over 50,000. It's the same scale, but this is ratio. This one is fraction. Okay. So you must be in position to know that. Okay. So another thing is that when you look at the representative scale, we say that 1 centimeter on the map represents 50,000 centimeters on the ground. When you say it like that, it's a representative scale. Okay, so representative fractional scale or representative ratio scale are basically the same. Literally, they are the same, but they're different in writing because they have the same values, the same digits we are using, But when you're writing, it's a fraction, it must be a fraction, a ratio, it must be a ratio. Okay. Now, what you must note that when you look at this here, this number here is in reality is bigger than this. Okay. When you look at it mathematically, 50,000 is bigger than 10,000. But in terms of the ratio representation, this one represents an enlarged section, and this one represents a smaller section. However, this one will have more details than this. Let's check. The larger the denominator, the smaller the scale, and the lesser the details it can have. Meaning that this one has got less details compared to what this one has. What is going to happen that this one is larger, it's exaggerated, it's enlarged. And I think you have observed that normally when you get a section from a topographic map and they put it on the orthophoto map, at times you might not be in position to see the street names or the streets on the topographic map. But because that small section has been enlarged, you will see the street names in most cases on the orthophoto map because it has been enlarged, and therefore you can be positioned to see exactly. So the larger the scale, so the more details it can have. I mean, the smaller the denominator, the larger the scale, and so more details can be shown on that map. And also a larger the scale is used, large scale is used if the map shows a smaller area. For example, 1 to 100, a lot of details can be seen on such a map. This is what I said, like 100, when you look at it mathematically, is smaller than 10,000. But in terms of details, it will have more details that you will see on that area because it will be larger, it will be enlarged. In other words, it's like it is zoomed out. So you'll have a lot of things to see there. Okay, that was the first scale. The second scale that you're going to look at is what you call the linear scale or line scale. Linear scale is coming from the word line. Okay, so when you look at this word here, a line, this one, it's a line, just like you can see a line. I think you can see this here. Sorry, you can see this line here. Okay. When you look at this line, it has got two sections. Can you see that, learners? Look at it. This line has got this section here, this one here, and it has got from 0 to 9, this section here. When you look at here, here it is indicated meters. Here it is indicated kilometers. What you must understand that from 0 going this way is kilometers. From 0 going this other side is meters. So this linear scale has got two sections. It has got the meter scale or the meter section and the kilometer section. What do we need to note? We need to note that when you look at this from 0 to 100 to 1,000 meters, it's the same as 1 kilometer. But this box here, 0 to 1,000 meters, this meter section, it has got 10 small sections. What does that mean? If it has got 10, the whole box has got 1,000. So when you divide 1,000, when you divide 1,000 by 10, you will find out that you will be having 100, meaning that each box here represents 100. In other words, that means the answer you can get when you're doing calculations with the calculator, you will have to be in position to get the same answer when you put it on a linear scale. I think I will do that in the later stage to show you how we can use a linear scale in order for us to get the answer. Okay. So we know that this horizontal line drawn on a map, which is divided into a number of equal parts. A line scale is accurate and no calculations are used. A line scale is divided into parts. This is what I said. It has the kilometer and it has the what? The meters. Okay. So hope you understand that, learners. But as we proceed, I'll teach you how we use this line scale in order to get the answers. It's very accurate, very, very accurate. Actually, it's accurate more than the calculations that you use with the calculator. All right, but we shall see how we get the accuracy is acquired. The word scale is another type of scale. A word scale is words, and this means that they are said verbally. Okay, it's a verbal statement. Just like the ratio scale is 1, 2 when you're using those dots. Now here you say it verbally. That 1 centimeter, 1 centimeter on the map represents. I want you to look at this word. The word says represents. It doesn't say it's equal to. Some of you learners make a mistake and you write this scale in terms of equal to. That is very wrong. For example, if you say 1 centimeter represents, okay, sorry for the ratio, represents 50 or 500 meters. This is very right, because 1 centimeter on the map is just representing. It is not equivalent to. So some of you write it like 1 centimeter equal to 500 meters. This is very wrong. Please avoid it. It will never be equal to 500 meters. It can't be, but it represents 500 meters on the ground. So understand, learners, that this one is very wrong. It must represent 2. So the right word to use is either represents or ratio. Okay. All right. So here, the scale is given in words. In other words, just like you see the word, this one to say a word scale, because of this word, it simply shows us that the scale is in form of words. Because of the word ratio, the scale is in the form of ratio. Those are the 2 dots. Because of the word, because of, what did we say, a line, the ratio is in form of a line. So from there, you get the details of how you're supposed to use those different aspects in different areas. Okay, so I expect learners not to keep on making such mistakes in map work, because it's costly. You end up losing a lot of marks because of making such slight mistakes, and you can avoid it. Okay. Okay, let's proceed. All right. How do we calculate distance? Remember, I told you that our main focus today's topic is distance. Is calculations. And while calculating, you must know that calculations cover a lot of aspects. For example, under calculations, we cover, let's see here, under calculations, we cover, number 1, we cover distance. Okay, we cover gradient, we cover area, we cover vertical exaggeration, we cover distance, area, gradient. Under calculations, we also cover magnetic declination and magnetic bearing. Okay, then under calculations, we also cover what else? Okay, if you look at all these aspects and you put them in your head, then there's no calculation you will find that will give you trouble. Okay, maybe we shall add on others as we proceed, but I want you to understand that these aspects are very important. So in case you as a child, you're going to write your paper, please make sure that you don't go to a paper minus putting all these aspects in your head before you write. Okay, gradient, area, vertical exaggeration, magnetic declination, magnetic bearing, true bearing, all those aspects need to be put in your head before you go to write your examination or any form of assessment. Now, calculating distance is the first aspect that I want us to look at. So while calculating distance, I want you to know that there are 2 distance calculations that we can look at. Take an example. We have a straight line distance, and we also have a curved distance or a winding distance. So when you talk about a straight line distance, it must be straight. Like you just put a ruler there, you get the distance in centimeters, you do your conversions, and you get your marks quickly. Now, if we talk about the winding distance, you have to use something that is not stretching, but it can be bent to cover all the widening areas, okay, or the curved areas. For example, you can use paper edge, you can use a thread, you can use anything to make sure that the distance is covered. I want us to look at this, learners. Here we have this line here, this black line here, that is coming from here to the end there. And now the question comes that calculate the distance covered by a black line covering, maybe let me say block 1A, I mean A1, A2, and B1 and B2. So if this is a line, it's a straight line distance, what do we do? Please learners, let's look at the procedure. The first procedure is measure. This measurement is sometimes referred to as the profiles, or you have to measure the distance, the straight line distance, and then the distance you measure, you convert it. Look at this. The first thing is with a line as in above. Okay, let me say measure the distance between these two, between one spot height 1268 and 1282. Now, what do? We first of all measure the distance. Whatever you use is fine, but measure the what? The distance. After measuring the distance, what's next? Let me say you have measured the distance from where, from this, on this map, from here to here. And after laying your ruler along this line here, you have come up with 3.8 centimeters. I think you must be knowing position. You must be in position now. You must be in position to use a ruler. When you're using a ruler has got two sides, or it has got different units. Some of you are measuring, the measurements you're using here is millimeters, because I know some rulers have got millimeters, some rulers have got centimeters, some rulers have got inches. So if you use a centimeter ruler, I normally advise my learners not to use any other units, because it disturbs a lot, because some learners don't know how to convert. So I preferably ask my learners to use centimeters, because when you're using centimeters, it becomes easier for you to know what to convert to. So when you look at this kind of map we're using, it is meant to be, or it is a topographic map. When you know that, when you understand that it's a topographic map, what comes in your head? What you get in your head is that a topographic map has got a scale of 1 to 50,000. Okay, so what does it mean? If you measure from this point here to this point here, and after putting your ruler along with this point, the units you are getting is 3.8 centimeters. So that is your measured distance. So what shall we say? We shall say that measured distance, or map distance, times the map scale. What will you get? You will get the answer there. So what have we measured along this line? We have measured that along with this line, it is 3.8 centimeters. I want you to see you're putting units. Why? Because you measured it in centimeters. If when you measured it in millimeters, you can put in millimeters, but you must be in position to do what? To convert. If you can't convert, it's going to give you a hard time to understand. So it's 3.8 centimeters times the map scale. Since this is a topographic map, what is the scale of a topographic map? Just a pause for a second, think about it. Okay, I'm just pausing for 1-2 seconds. What is the scale on the topographic map? Okay. Yeah, I can see learners are thinking about the scale. So the scale is 1 to 50,000. Okay. And if this is the scale we have, and what shall we do here? We shall multiply by 50,000. Okay. And after multiplying by 50,000, remember, what does this scale mean? 1 centimeter on the map represents 50,000 centimeters on the ground, meaning that this 3.8 centimeters is what you measured on the map, on the piece of paper. So if this is what is on the paper, you must convert this distance to reality distance. What will it be if I go where this map is coming from? But you know that each unit on the map is representing 50,000. So what will I have? And what will it be? What will be the units? So what shall we do? So we multiply. Okay. So after multiplying, what will you get? After multiplying, what will you get? The multiplication is going to be that 3.8 times 50,000. What are you getting? You are going to get 175,000. But this is what? Centimeters. You see that? Meaning that the map distance that you have is 3.8 centimeters. The ground distance or the reality distance is 175,000 centimeters. So that is the ground distance. But according to the question, in this case, the question is saying that the distance, the answer, let me say the answer, the examiner wants the answer in kilometers. Okay. The examiner wants the answer in what? In kilometers. What shall we do? We shall say that this answer you got here, divide it by 100,000. And what will you get? You'll get the answer to be 1.75 kilometers. Meaning that this distance you are seeing from here to here, it is the paper or the map distance. But in kilometers, in where this map is coming from, it is 1.7 kilometers. That is one way of getting the answer. But don't forget that if you go this way, you still get the same answer. If you cannot go this way, what do? You come here. I want you to see here. When it is a topographic map, 1 centimeter represents 50,000 centimeters. Also, 1 centimeter can represent 500 meters. The same way 1 centimeter is representing 0.5 kilometers if it's a topographic map. If it's an orthophoto map, the same way, because the scale here is 1 to 10,000. So in terms of meters, we're going to use 100. In terms of kilometers, we're going to use 0.1. So we come back here. And we say, this map we are using here is a topographic map. So when you check here, topographic map, if I want the answer in kilometers, what am I multiplying with? 0.5 kilometers. So I come here, I will say that 3.8 centimeters times 0.5 kilometers. What will I get? The answer you're going to get is going to be 1.75 kilometers. Do you see that it is the same answer, guys? It's the same answer. But now you must understand that here you must have this in your head. That if it's a topographic map, I use 0.5 if they want the answer in kilometers. If it's an orthophoto map, I use 0.1 if they want the answer in kilometers. If they want the answer in meters and you are dealing with the topographic map, please learners, don't forget, we use 500 for the topographic map. We use 100 for the orthophoto map. Hope learners, you won't make any mistake anyway, okay? Because those mistakes cost you a lot. Imagine this section or this part here is saying 4 marks, and then you lose all the 4 marks because of that, or 2 marks, and you lose all the 2 marks because of that. And that mistake can be avoided. So you have 2 ways. You can either go this way or you can go this other side. Whatever is easier for you, you can use it such that you can get everything right. Hope that is okay, learners. That is for the straight line distance. In scenarios, I want you to look at it in the same scenario here. Can you see? Then check which scale is it using, multiply, and you see that you get the answers here in centimeters. Then you convert the centimeters to meters. Then you convert the meters to kilometers. It depends on how you want to go about it. Okay, it depends on how you want to go about it. But all in all, that is how we do the calculations. Okay, so if it is orthophoto map, I expect learners to be knowing that. Let me take an example here. When you look at this area here, it's coming from the topographic. Imagine, please just imagine. I'm not saying this is the orthophoto map. Just imagine, this is orthophoto map. Okay, and this distance that this line that you are having here is drawn on the orthophoto map. And after measuring this distance here on the orthophoto map, it is giving you 3,8 centimeters. What will it be? So I think you know what to do. There, you just get the 3,8, okay? And you say 3,8 in terms of centimeters. Sorry, it will be 3,8 centimeters times 0,1. Okay, that is if you use this method here. Okay, if you use this method that I put here, it's going to be 3,8 centimeters times 10,000. So the answer you're going to get, you're going to divide it by 100,000. So when you divide the answer here by 100,000, the answer you're going to get is going to be that very answer. Okay, so what you'll get will simply means that will be the distance in kilometers. In other words, 0,38, okay, times 0,1, I think you'll have to get 0,38. Okay, and this is going to be kilometers. Okay, so in this case, if this was orthophoto map, this is what I expect to see. If it is a topographic map, please use the previous one that we used. Hope we understand each other, learners. Okay, so boys and girls, having seen the distance which is straight, we must understand that we use the different approach if we are dealing with something that is not straight. Take an example, the distance for this road here from the beginning to the end. You can see that this road here is not straight, it is winding. Can you see that? So what do? Get a piece of paper or a thread, lay it along the feature you are measuring. Let me say in this scenario, it's this road here, from here to here. So you lay it along this road here nicely. Don't stretch it, because when you stretch it, let me say you are using a thread that is stretching, or anything that is stretching, it simply means it's going to give you wrong measurements. So what do? You don't stretch it, you lay it along that line. Then afterwards, you take this distance to the ruler, measure the distance in centimeters, and then you follow the same procedure to convert. Okay, if let me say this distance here, after laying a thread along this, you see when you lay thread here, you put it from here. If it winds, you also wind the thread. If it changes direction, you also change along this line. So afterwards, you're going to hold a thread that is straight. So that thread, you lay it along on the ruler, and you get the answer in centimeters. If not, you use a divider. I think, learners, you know a divider in your mathematical set. A divider has got two sharp points. So when you lay a divider along that thread, you just put it along the thread and you get the distance. You transfer the divider to the ruler and you get the centimeters. So those centimeters are the ones you convert using the same procedure. If it's a topographic map and they want the answer in kilometers, 0,5. If they want the answer in meters, 500. If it's an orthophoto map, they want the answer in meters, 100. They want the answer in kilometers, 0,1. Like that. So you won't find any challenges at all. Okay, so that is distance, learners. I hope we understand each other. We are at par and everything is okay regarding distance calculations. So if you still have any problem regarding distance calculation, feel free to contact me via Thundereduc platform, or to ask questions via the Thundereduc platform. I'll be in position to reply to you and answer your questions. But learners, I want you to know that map work is very easy. Map work is the easiest section to pass. And I want you to understand that in any case you understand map work, it's free marks. If you really understand it, it becomes free marks. So I don't expect my learners that are now going through this lesson to still fail map work. Okay, most especially these simple things. So okay, we are done with the distance, or actual distance, or straight line distance, or curved distance. So that is exactly what can be asked. Let's proceed and look at area calculation. Let's proceed and look at area calculation. Area calculation, in other words, the area is calculated to determine the actual size of the ground on the ground. And in this case, we'll look at a feature or a demarcated area that you're going to look at. Under this line, we are looking at the area that is put down here. And when I look at it the way it is, what comes in my head is that this is a topographic map. And the moment I see a topographic map, I'm thinking of the scale that is now meant to be used on the topographic map. Okay. So what we can do here, or what can we do here? We go back here and say that while looking at the area can also be calculated in kilometers, and also it can be calculated in meters. So learners, I want to electrify something here. When you look at the formula that is now being used here, it is area, which is, it's area which is equal to L times S in two brackets times B times S into brackets. This formula normally in your exams is not what is given. In your exams, they normally say area is equal to L times S. This is what normally comes in your exams. Now, when you see such a formula in your exams, learners, please don't hesitate to expand it. You can have the formula like this in your exam, but just know that area is equal to L times S times into brackets times S, B times S. Sorry, this is L times B. Okay. Now, if it's like this, that simply means you will not forget what to do. You will not forget that I have to multiply everything by the scale. Otherwise, if you go with this here, in most cases, you forget to multiply everything by the scale. Yet, the area we are looking for the area on the ground, actual distance. And therefore, to get the actual distance, you must make sure that you consider the scale that is used and which map is being used. Take an instance that when you come here, when you come here, oh, I want to create space, sorry for that. When you come here on this area that the part that is given, look at this. By looking at the way it is even indicated area covered by the orthophoto map. But this must be on the topographic map. The way you see it's in color, you can see the features with symbols. Remember, a topographic map basically uses more of symbols and so graphs and so on and so forth. So these contour lines and the way it appears in color, it simply tells us that it's a topographic map. What are we measuring? We said that according to the formula, we need to measure the L and the B. You come here. When you look at this part here is 7.4 centimeters. This part here is 9.8 centimeters. By you looking at the units or the answer that you got after measuring, it clearly tells you which one is the length. Okay, normally the length is longer than the breadth. So you will find out that the L must be bigger than the B. In most cases, even if this part here is turned upside down and this part is here, this part is up here, you must note that even if it is turned upside down, this line that is longer should be the length. Though I know after calculating, you will get the same answer, but you have swapped the concept. The concept is that length is the longest part than the B. So if you just put this under the length instead of under the B, instead of putting it under the L, you will lose marks. Sometimes you will be penalized for that. So please let us try to avoid some such minor mistakes. So when you're given this formula, which is L times B, normally I tell my learners to expand it, write it in an extended formatting. The moment you write it like this, it is going to come into your brains that what is A? A is the what? Is the area, which is equal to L. What is the value for L? L, you have just measured it that it is 9.8. So you will come here and you say 9.8 centimeters times the scale. What is the scale? Which map am I using? I'm using a topographic what? A topographic map. Oh, I'm using a topographic map. What is the topographic map scale? The topographic map scale is 50,000. Put it in brackets. Remember, this is also what? Centimeters. Okay? Put in bracket times. What is B? The value for B is 7.4. I come here, I say 7.4 centimeters times. What is the scale? Obviously, it's a topographic map. Okay, the topographic map, what is the scale? Is 1 to 50,000. So you say times 50,000 centimeters. You cross the brackets. Why am I putting this? Why am I multiplying by 50,000? To convert the centimeter distance, the actual distance in centimeters on the ground. So when you multiply that, what will you get? You will find out that it's going to be 9.8 times 50,000, which gives you 9.8 times 50,000, which gives you 5. Okay, 50,000, 9.8. This is centimeters. Okay, then you go. Sorry. It is multiplication. It is 9.8 times 50,000. It gives you 4. It gives you 4,900. Okay, 490,000. Okay, this is centimeters. Then you come here, 7.4 times 50,000. and you get that is 370,000 centimeters. Okay, so I have this, it's all centimeters. Okay, it simply means that the paper has got 9,7, but in reality, where the map is coming from, it is 490,000 centimeters in reality. Just the same way the B has got 7,4 centimeters, in reality, it is 370,000 centimeters. Now, these are centimeters, okay? But according to this, the question wants the answer in kilometers, okay? So because the question wants the answer in kilometers, here, can you see it in kilometers? So what do? I come here, I change the centimeters to what? To kilometers, okay? So that means this divided by 10,000, divide by 10,000, by, sorry, not 10,000, 100,000, and you also divide by 100,000, such that is 4, go with this 4, and therefore I'm remaining with how many? 1 place, I move it here, it becomes 3,7 kilometers. That means this one has changed from kilometers, from centimeters to kilometers. Okay, now I come here, so this is this one, 1, 2, 3, 4, 1, 2, 3, 4. How many places am I moving? It's 1, which becomes 4,9 kilometers. So the answer is going to be kilometer times kilometer. What are you getting? You get kilometer squared. Now 3,7 times 4,9, what do you get? 3,7 times 4,9, what are you getting? You get 18,13. So this answer you get is in kilometer. This is the area if you are using kilometer. So in scenarios whereby you were supposed to use meters, what will you do? It simply means that after multiplication is here, you don't multiply by 10,000, you don't divide by 10,000, you divide by 100. Even here, you divide by 100. Someone can ask me, but sir, where do we get this? Why do we multiply by 10,000? What do we multiply? What do we divide by 100,000? And why do we divide by 100,000? I want you to remember these, learners. Remember this so that you don't forget. Okay. King Henry does not mind drinking cold milk. I just want to deal with what I'm dealing mainly with, kilometers and what? And meters. So this is kilometers, this is centimeters, this is millimeters, and this one is meters. Most important. So if kilometers, how many spaces shall I have? Those are the spaces. This one, 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 those are the spaces. And here, those are the spaces. Meaning to say, if I'm moving from here to here, okay, I will divide by what? The spaces, the numbers are here. You see, it's 100,000. That's why here I divide by 100,000 to change the centimeters to what? To kilometer. The same way here, if I'm using meters to kilometer, I will come here and I will use this number here. You see that? So that means I will divide by 100 here, which gives us the answer that is very, very okay. Okay, so if you're changing from centimeters to meters, that means you are going to be here, still using 100. So while looking at those aspects, it is going to be very easy for you to remember. That's why I encourage learners, if you're given L times B, extend it so that on the extension of this area of this formula, it will be very easy for you to remember what S stands for and what B stands for. Under the same line, if I put this one away, I want to see if really, because I don't want you to say, but sir, that we are forgetting, or that site is too long, we can't remember. That's why I'm giving another option. Okay. The other option here is that, what shall we have? We shall say that area, still you expand it, area is equal to L times S into this B times S. What is the value for L? The value for L is 9,8 centimeters times 0,5. And here the value for B is 7,4 centimeters times 0,5. You know that this 0,5 is the scale. But why are we multiplying? We are multiplying so that we can convert the paper distance or the distance on the paper to the reality distance, the ground distance. So that when you multiply this by this, it still gives you, okay, 4,9 kilometers times 3,7 kilometers. So the final answer you're going to get is going to be 18,13 kilometers squared. I want you to understand that the moment you put kilometers here and you put kilometers here, I will know where the kilometer squared is coming from. But if you don't put kilometer squared and you end here and you put kilometer squared, the question is whether this kilometer squared comes from. It's coming from kilometer times kilometer, kilometer squared. 4.9 times 3.7 gives you this one. That's when you get the final answer. So there will be no way you'll be penalized for that. So please ensure that you put units. And like I told you at the beginning, that while doing calculations, you follow all the steps. Okay, you follow all the steps. So everything you do, you make sure that the steps are catered for. Every step you do, it has a meaning. So if you don't respect the steps you are doing, it simply means that you're going to be affected, and eventually you will jump other steps, which will result into loss of marks. And remember, we are doing this to maximize marks. So I don't expect my geography student to fail to maximize calculations, GIS, and interpretation. Those 30 marks, they look to be for free. Okay, but you can apply your geographical skills, and then, yeah, we proceed. Now, I think you have seen this, 4,9, 3,7, and the answer is there, which means the final answer is this. And how do you get this? I've taught you how to get that. Okay, remember, I'm reminding you that don't forget to put units. That's why you see here there's kilometer square, there is kilometer here, there's kilometer square here. So that here at the end, this times this I get kilometer square, this times this I get this. If you don't do that, you're missing a point somewhere. Okay, now that is area. So this question is basically asking area in kilometers. What about if they ask area in meters? Area in meters, you just need to take away this other. It's the same, you follow the same procedure here, you follow the same procedure here. But now when it reaches here, you convert this to what? To meters. So you divide by 100, you divide by 100. Then at the end of it all, you will reach your final answer in meters. Okay. Now, the next aspect that I want us to look at is the aspect of true bearing. True bearing is the same as direction. However, true bearing appears in you measure degrees. In other words, you use degrees, use angles. We follow the same procedure, but we use what? We use angles. In other words, at times they ask true bearing and direction, which one is very accurate? You will find out that true bearing is very, very accurate, because it is using angles. Okay. Now, when you are dealing with this true bearing or dealing with angles, what do we do? You must find out that you need this instrument, this one here, which is known as a protractor. This protractor is the one you are going to lay on your page so that you can measure. But what is more important here is for you to know which one is the starting point in my question paper. When you are reading and you know your starting point, then it becomes very, very easy. Take an instance. Look at this. Let me say, in this case, this question is saying, what is the true bearing from this trigonometric station to this spot height 1403? Because of the word from trigonometric station here, that means I have to start from here going this way. What is the first procedure? The first procedure is for you to draw a line joining those two places. I always encourage learners to draw that line when it is very long, such that when you put your protractor, you can still see the numbers and read them nicely. Okay, so from here, they say from the trigonometric station here to the spot height here. What do? We come to the trigonometric station and you draw the cardinal points. Cardinal points are these ones here. You see, here they say cardinal points are here, this here, where you say this one is 0, this is 90 degrees, this is 180 degrees, this one is 270, okay, and this one here is 360 in terms of angular distance. So when you look at it, it simply tells us that you must know that when you're doing your measurements, you move clockwise. Remember, the first step you did is to join those two places with a line. Which line we drew straight joining the two places. So when you're drawing this cardinal point, you must make sure that this cardinal point is straight in relation to these other lines that are drawn straight in this map, such that you don't get any angle that is not accurate. So what do? We start from here, 0. We measure moving clockwise until when you meet the line that is joining the two places. So when you meet this line, the angle you're going to get is going to be the true bearing. Take an instance. This is 90, right? 90 plus 90 is 180. So 180 plus this angle here. Remember, this angle is not reaching another 90. It is somewhere around there, 80 and so on and so forth. So what do? You get this protractor here. You lay it. Now, the first protractor, you're going to lay it from here to here. That means if you're moving clockwise, it's going to be laid like this. So in this case, you bring this one here. When you lay it here on this line here, just like the way it is here, you lay it here. And when you lay it here, you make sure that this point here is 0 and here is 180. You see here? Here is 0 and 180. I want you to see 0, 10, 20, 30, 40, 60, 80, 120, 140, 60, 70. This must be 180. So this line that you drew like this should be sitting exactly on this line. We don't use the edge here. We use the line that is having 0 and 180. Then after laying it like this, this is 180. So you say 180 plus this angle here. So what do? I change it to look like this. such that when it looks like this is going to be 0 and this is going to be 180. So you lay it along this line so that this one is 0 and this one is 180. So when it becomes 0, 180 or 180, 0, you count from here. That means if this is 0, how many are they to reach this line that is joining the two places? In this case, I will say it is 81. How will it be? It simply means that it's going to, the line that is leaving this point of intersection, cutting across, it should be sitting somewhere here. Or in other words, somewhere here. You count 0, 10, 20, 30, 40, 50, and you see when you meet this line that is cutting across, that's why I say draw it long, so that when it cuts like this, so you read the number you see. Some of you don't know how to read. Don't use this number inside, because the number inside is starting from 170. That means the one that for inside is coming from here, going anti-clockwise. But for us, we said we are moving clockwise. So we use the number outside, which is 10, until when you reach this line that is joining the two places, the answer you get is what you add. If I add 81, what will I have? I'll have 261 degrees. So 261 degrees becomes the true bearing. Okay. In other words, to recap it all, the true bearing, you must make sure that you get to know which one is the starting point and which one is the ending point. And the moment you know which one is the starting point and which one the ending point, you must also be in position to tell that where are the 2 points? Have I joined them with a line? Have I joined the 2 points with a line? How is clockwise supposed to be? When you are drawing your true north, the true north for the cardinal point should be sitting straight. Okay? It should be sitting straight. All right. That is true bearing. Now, having seen the true bearing, okay? Having seen the true bearing, we can also proceed and look at magnetic declination. But when you're looking at magnetic declination, you must understand that how do we get magnetic declination? How important is magnetic declination? In most cases, magnetic declination is the angle between the true north and the magnetic north. Look at this. This one here. I think, actually, why do I draw it? I draw it again. It's here. You see this line here? I think you start by drawing this line here. If you remember very well that this line, you drew it like this, okay? And this becomes the true north. So this distance, the angle between the true north, the angle between this, between the magnetic north, between this magnetic north and the true north, this is magnetic what? Declination. Okay? Now, let me say this is point A, and this one is point what? Point B. Then you drew a line joining A and B. So the angle between the true north and the 2 points, which is now A and B, becomes the true what? The true bearing. So if this is magnetic declination, and this is the true bearing, you remember somewhere you use the magnetic declination and the true bearing, whereby you say magnetic declination is equal to, or magnetic declination plus true bearing. You get magnetic bearing. What does that mean? You have to add the two. Come to your graph. When you add this angle here from the magnetic north plus the true bearing, what do you get? You get magnetic declination. Magnetic bearing. So magnetic declination plus true bearing, you get magnetic bearing. So you cannot get magnetic bearing before you calculate magnetic declination and before you get the true bearing. There's a question that I came across that was saying what is the importance of calculating magnetic declination? It is important to calculate magnetic declination because you need to determine the magnetic bearing. So otherwise, if you miss out magnetic declination, you won't get this. If you miss this one, you won't get this. So we need to understand those aspects clearly before we proceed. Okay. Learners, boys and girls, if you check here, the true north is a definite fixed point on the globe where all lines of latitude meet. That is obvious. It will never change. Now the magnetic north magnetic north is measured with the compass, and it is not fixed. That means it can change. I think you have seen it when you hold a compass, the magnetic north keeps on rotating. So the magnetic north is determined by the magnetic field. So there is a question that also came across, which was saying that why is the magnetic north and the magnetic south keeps on changing? The magnetic north and the magnetic south keeps on changing because it depends on the magnetic field that surrounds the earth. So the magnetic field, if the magnetic field changes, it automatically changes the magnetic north, and it automatically changes the magnetic what? The magnetic south. So the Earth's magnetic field is generated by the mineral constituents of its core layer. The core of the Earth consists of the nickel and iron. I think you remember this in grade 10. Okay, the nickel and iron, I remember we said which is highly magnetic. So nickel and iron is highly magnetic, so it determines the magnetic field. So if the area has got a lot of magnetic, is a lot of coal and iron, it simply means that the magnetic field is also going to be very, very much. Okay, so the Earth's magnetic field is not static. It keeps on changing. It changes, and thus the magnetic north also changes. Okay, so in South Africa and in the rest of Africa, the magnetic north is always west of the true north, and it moves westwards in South Africa and the rest of Africa. The movement changes depending on the magnetism of the earth, whether the strength of the magnetic field is high or low that year. This is to say the change is determined annually and it expressed in minutes. If, for example, the change is 2 minutes east, while the magnetic field is 2 degrees west, then we subtract east from the magnetic direction. But if the change was west, then we will add the west to the magnetic field because they will be both moving in the same direction. Okay, so I think you need this background because in most cases, these questions are asked a lot, and they are free marks because if you happen to understand these aspects, it becomes very easy, very, very easy for you. So when we go in the details of calculation or calculating the magnetic declination and magnetic bearing using the true bearing, this box here is very, very, very important. This box, mainly those ones who are dealing with English, we use this. Every information we are using is here. Let me take an example. We are calculating now. Look here. We say that magnetic declination, which year are we in? It's 2022. So the first step is going to be that difference in years, which is 2022 minus the year that is indicated. Now come here. What do you see? You see here, somewhere here, that mean magnetic declination, 18 degrees 7 minutes west of true north, and the year here is 1981. And then somewhere here they put 1971, 1975. Please understand, learners, we don't use this because this is not a specific year. These are range of years from this year to this year. We normally use a year that is specific, which is 1981. Okay, so we come here. Oh, sorry. We come here, we say difference in years, we said it's 2022. 2022, we say 2022 minus 1981. What's the difference? 2022 minus 1981. The difference is 41 years. Okay. Now, some of you make mistakes and say 1981 minus 2022. When you minus that, it will give you negative years. We don't have years in negative. Please follow the right procedure. It's always the current year minus the year on the map. Okay, so which is 41 years. Which is, step number 2 is that we need to know the mean annual change. What was the change each year? According to this map, the mean annual change each year, or annual, the word annual means yearly. So mean annual meaning that what was the change for the each year, which gives us 2 minutes west. So if it's 2 minutes west, what is next? Total change. Total change, it simply means it is 41 years times 2 minutes west. What shall we get? We get 82 minutes west. That means from 1981, 41 years have passed. But each year that passes, the change that takes place is 2 minutes and it moves to the west. So from 1991 to 2002, the change that would have taken place in total is going to be 81 minutes west. We go back and say that in 1981, what was the magnetic declination? The magnetic declination in 1981 was 18 degrees 7 minutes west. That was for 1981. What is the change that have taken place from 1981 to today? I want you to look at this. This number is bigger than 60. What do we do? When if it's bigger than 60, we say 82 minus 60. What are you getting? You say it is 1 degree. How many minutes are remaining? It is 22 minutes. Okay. Where do we get this? You know that 1 degree is equivalent to 60 minutes. Now we have 82 minutes. How many degrees shall we have? We shall have 1 degree and we shall be remaining with 22 minutes. So instead of putting 82 minutes westwards, we shall say it is 1 degree 22 minutes west. Okay, now, so that is what we have. So what shall we have? We say that in 1981, the magnetic declination was 18 degrees 07 minutes west. But since that time, 1 degree has passed and 22 minutes have passed west. Since we said they are moving westwards, we shall add. But we only add degrees with what? Degrees. Therefore, 07 degrees plus 07 minutes plus 22 minutes. What are we getting? We are getting 29 minutes west. Now, 18 degrees plus 1 degree, we are getting 19 degrees. So the magnetic declination for 2000, this is now for 2022. So the magnetic declination for 2022 is 19 degrees, 29 minutes west. And you can see that the numbers increased because the numbers increased because the movement was westward. All right. So that becomes the magnetic declination or the calculation of magnetic declination for what? For 2022. That is magnetic declination, not magnetic bearing. Okay. Not magnetic what? Magnetic bearing. So I expect learners to familiar themselves with that, such that if that number comes, we don't fail. Now, we understand that after calculating magnetic declination, then we can determine, you remember the formula I said, that it is magnetic bearing equal to true bearing plus magnetic declination. What is the value for true bearing? We said it was something like 261 degrees plus, what is the magnetic declination? We have just calculated it and we said it is 19 degrees. How many minutes? We said it is 29 minutes west. And now when you add, what are you getting? 261 plus 19. Remember, these are degrees. Okay, we add 261 plus 19. What are you getting? I think this is 0, which is 10. You take 1, 6, 7. Okay, 8. And how many here? You remain with a 2. So it becomes 280 degrees. How many minutes? 29 minutes west of true north. Okay, so that means the true bearing, the magnetic bearing, you can only get it if you know the true bearing and the magnetic declination. Then you add them together. But learners, don't forget that we add minutes with minutes and degrees with what? With degrees. So magnetic bearing is a measurement of the angle between the magnetic north line and the line joining the two places. So this is how we calculate it. Okay. I would love us to continue and look at calculating distance, speed, and time. But because of the interest of time, we shall end here today. We shall start from there next time. Thank you for joining. Thank you for watching. Please ensure that you practice these things and you pass. All right. How is the South Africa's economic sector looking like? South Africa's economic sector has got basically 4 main sectors, which starts with the primary sector. From the primary sector, we proceed to the secondary sector. From the secondary sector, we go to the tertiary sector, and then you look at the quaternary sector. These 4 sectors are the main sectors that are making up the South Africa's economy. However, there's always another 4th sector that is 5th sector that is added there. Sector number 5 that is always added there is the quaternary sector. But you need to know, what does each of these sectors mean? Okay. So the economy of South Africa runs on those different sectors. In this case, we have what they call the primary economic sector. The primary economic sector, basically, what does it talk about or what does it deal with? This sector deals with the extraction of raw material from nature. We extract raw material from nature, in other words, or from the environment. Such activities whereby you go and extract raw materials from the environment, we call it primary sector. In other words, there is no processing, There's no turning raw materials into a final product. The only activity is you get the raw material from the environment or from nature. Such activities include farming, fishing, mining, forestry, tree logging, extraction of oil, stone quarrying, all those activities primary activities. So when you look at the primary activities, you just remember that, oh, wherever there is primary, it's the starting stage, extraction of raw material from nature. Okay, so you must be in position to remember these activities that we have here. Okay, that is primary. All right, then from primary, we have another activity that follows. That is the secondary activity. This activity here. This activity, which you call the secondary activity, which means it is dealing with the changing of the raw material into a useful or a finished product. In other words, if here in the primary, you were getting raw material from nature and you don't process it, that means here there is processing of raw material so that you can get a final product. Sometimes you find out that this secondary sector deals, sometimes others call it this manufacturing sector, or the sector where there is manufacturing of goods. In other words, you add value, the raw material, such that you can have a final product. You produce a final product. In this case, these activities deal that processes or change raw material into useful product or useful goods. Processed goods are sometimes referred to as value-added goods. You add value to those goods. For example, we have these activities here. Metalworking is an activity that is under secondary sector. Smelting, there is automobile production, textile production, chemical and engineering industries, aerospace manufacturing, energy utilities. We have engineering, breweries, bottlers, construction, and shipbuilding. All those activities are under secondary. You are turning raw material into a final product. I also want to use another example. Sugar is a product that you get from sugarcane. Sugarcane, when it is still in the farm, it is that activity. When you're in the farm, you're cultivating, you're doing all the activity is primary. So that sugarcane is then squeezed. You take the sucrose out, you take it to the factory, they make for you sugar. The sugar that is made out of sugarcane is in the sector which you call secondary sector. So you can see what we mean here. Here you have manufacturing, okay? You are processing raw materials and you make a product out of that, okay? Then, sorry. Then we proceed and look at something else, which we're talking about now. The secondary, the next activity after secondary activity is what we call the tertiary activity. When you look at the tertiary activity, we are basically focusing on that activity that deals with the provision of a service, okay? And now, in this case, if you have looked at this as a secondary, then we go to tertiary, meaning that it is the activities that involve provision or distribution of what? Of services to businesses, to consumers, etc. Okay, for example, transport, telecommunication, hospitality, public health services, tourism services, media services, that is radio and television, health services, waste disposal services. In other words, something that is important in our life, we need it in our life, but we don't really see it. We don't even detach it, but you need it. It adds value to you. I will use the same example. Sugarcane in the farm is under primary. Taken to the factory, they make for you sugar is under secondary. but they don't sell sugar in the factory. Sugar is taken to shops, to ShopRite, to Pick and Pay, to any other shop that is selling that final product. But you must know that that product that is taken there, it uses transport. There are some people who transport the sugar to the factory, to the shops, to say Pick and Pay, to say ShopRite, and so on. So those products that are taken there, or when the products are taken there, those people who are transporting, they are providing a service. So their activity falls under tertiary activity. You go to the doctor when you're sick, you get medical attention, or you get treated, you get better, you come back when you're okay. So doctors provide the service, teachers provide the service, lawyers provide the service. It is going to benefit you, you'll feel better, but you don't even touch it, you just appreciate what is done, and then you move away. And you know very well that there's nothing for free. You even sometimes pay for that service. However, if it's provided by the government, you know that it's the government that pays, okay? So we go on and look at another activity, which you call another economic sector, which is now the quaternary sector. The quaternary sector, or the quaternary economic activity, these activities basically deal with the higher provision level of the service. In other words, it is information and technology. It's sometimes, to make it a little bit easier, we say it is a sector that deals with the research. People go think of something whereby they come up with something that is new, something that is improved. So that one is going to fall under quaternary sector, or quaternary economic activity. Under those activities, what do we see? We have ICT, we have consultancy, we have research. I'll go back to the same activity. We talked about sugar. We started from sugarcane from the farm, which is primary. We talked about it in the factory, which is whereby they manufacture for you sugar, and we say that is secondary. We talked about the people who are transporting sugar to the shop. We know those ones who are selling, we call them cashiers. They are at the till selling for you, or you go buy sugar, they sell to you the sugar. So those ones are providing a service. But we also know that there are sometimes when they need to come up with innovations. Take an example. You find out that sugar basically grows very well where we have enough rainfall. And then that's why you see most of the sugarcane is grown in KZN, because KZN receives over 1,000 millimeters in a year. So when you look at that area where sugarcane is grown, they can think of, how can we improve the product? How can we make sure that the productivity or the processing of sugar does not stop? So they start thinking of how they can do these things. So they do research. They go to offices, they take their research, they came up with new inventions, and then they improve the productivity. So you find out that through that, they come up with, let me say, genetically modified seeds and so on. That can also help to have a proper product, or a better product. In that case, that sector where there is research done, technology, it is under what we call quaternary sector. So it is basically a research. Okay, this is a research. Then the research and technology and information, we have ITC here. So you look at what happens in the globally, what is new, what needs to be improved, so that we can equate ourselves to other countries that are producing the same product and is on the same standard. So you have to research globally, you have to use internet, you have, now that's this sector that deals with this is what we call quaternary sector. Now, the last sector that I can talk about that is not here, but it is also important, is what we call the quinary sector. So with the quinary sector, what does it do? The quinary sector, basically, it deals with decision making. You see, these ones are doing research, they come up with something new, but they don't make decisions. The decisions are basically, let me say, made by some other bodies. For example, judiciary, they take decisions, okay? For example, the government. So you do research, you find out something new, and then the government says, yeah, you have to wait for it to be approved, okay? So that it can be now operating, or it can be in the market. So under that line, all those sectors that deals with decision making is falling under disciplinary activity. It's not part of, it's not here, but it is also another sector that is very important. So we must know that as learners, that are these sectors important? Yes. That is when we are going to look at its contribution to the GDP. But before we look at its contribution to the GDP, let us understand what is GDP. GDP, first of all, it stands for gross domestic product. P stands for product. Okay, so if it stands for gross domestic product, what does it mean? We look at the total value of goods and services that are produced within a country in a particular year. Okay, so we say that if you look at those goods and services that are produced in a country, what is the contribution? Which one contributes more? Do you think the primary sector contributes more? Do you think the secondary sector contributes more? Or it is the tertiary sector that contributes more? You understand? So when we analyze this, we need to understand its great contribution to the GDP of the country. Okay, in that, by understanding its contribution, you will know whether it has declined, whether it has improved, and so on and so forth. So when you look at the primary activities that are taking place, take an example: mining. We have mining, we have agriculture, all taking place in the same province. What is its contribution? In this case, you find out that that is primary. Then when you look at this, this is just looking at the different provinces and their contribution to the GDP. Let us just try to analyze this graph. Look at this. You know very well that Gauteng is basically known for industries. So it contributes basically in that case. And that's why they are saying, according to this, it is the biggest contributor to the national grid or to the economy of South Africa. Okay, so we look at that and we understand that GDP contributes the highest to the, Gauteng contributes the highest to the GDP of South Africa, and the Free State contributes the lowest to the GDP according to this. But now when you look at this, look at Free State, it contributes 5%, then followed by Northwest, which is 6%. We have Limpopo, which is 7%, in Mpumalanga, Eastern Cape, Western Cape, KZN, and we also have Gauteng. Those are the different 9 provinces and their percentage contribution to the national grid. Okay, so all these ones have got different activities taking place in these different sectors. Even these activities are taking place there, but you find out that which one contributes more. We need to understand that. Now, by just bringing in this aspect, look, primary sector contributes 11.4%. Secondary sector, in this case, it has its contribution of 7.4%. Tertiary sector contributes 3.0%. Okay, and all those are different sectors. When you look at them, look at this contribution of the secondary sector. This is just recent, 2019. There was a general decline in the secondary sector production of South Africa, which declined to this. So manufacturing, look at this. Now that this is the average contribution of the secondary sector. Okay, then we also have the tertiary sector, which talks about, in other words, tertiary service, trade, transport, finance, all those personal services, government, they contribute this much, okay, to the economy of South Africa. Okay, now by looking at those different sectors, you need to know which one contributes more, which one contributes better, what is its value, and so on and so forth. So here we are saying the contribution of the secondary sector, or the contribution to South Africa's economy by value between 2019 and 2020. If you remember 2020, we had a very big setback of COVID-19. So there was some factories closed down, some shops closed down. It is so that means all the sectors of the economy were now being affected. This is what is happening. They say that in 2020, look at the statistics. In 2020, we look at each sector's contribution as it is measured in percentage. Okay, look at that. This is construction, and we said the construction is under which sector? Look at electricity. Okay, look at agriculture, look at financial, look at government, trade, manufacturing, transport and communication, mining, personal services, extra. In this case, you see that finance contributed 20%, which is the biggest contributor, and finance is under the tertiary sector. Okay, government, it's under the tertiary sector. Trade, it's under the tertiary sector. So you will find questions, learners, that are saying, explain, calculate the total contribution of the tertiary sector. That means you must be in position to tell which one is a service. Yeah, personal service is a service, financial service, government service, trade service. So you add them up, transport and communication service. You add them up, and then you come up with the percentage and to know which one contributes more. This is according to the statistics that came out in 2020. Okay, then sorry. Sorry. Besides that, we have besides that, sorry for that. Besides that, we look at another graph here. We need to analyze another graph that we have here. The graph that we have here is showing the relationship between GDP and unemployment rate between 2010 and 2020. So this one is analyzing. You can see that this shows the GDP growth and unemployment 2020. You see how many people were unemployed, how many people were employed. 1 million people lost jobs in 2015. You understand? Now, this one is trying to analyze how the flow was in relation to the GDP. In other words, you know very well that if people are unemployed, that means they contribute less to the GDP. When people are employed, they will be working, and therefore they will contribute to the GDP. Okay, so under that line, you must understand, learners, that what just shows how things are happening. Remember, in this section of economic geography, there is a lot of graphs that are used. Okay, there is a lot of graphs that are used. There is a lot of graphs that are used, and these graphs are very, very, very important. So you must be in position to learn how to interpret the graphs. It might be a pie chart, it might be a bar graph, it might be a line graph, and so on and so forth. So that is the issue that you need to understand, good people. So here I have some of the activities that I would love learners to test themselves. Okay. And the answers are down there, but I don't want to check the answers. I want you to look at these questions and see if you can answer them. Which mining is an example of economics, of which economic sector? Which one is mining? Think about it. I want, if in any case you can write your answer somewhere down and you test yourself, then when I tell you the answer, you just tick yourself. That will be better. It will be okay if you assess yourself under that line. Mining is an example of this activity. Which activity? You know very well that mining falls under primary sector. Okay, Then we proceed. The sector concerned with the provision of a service is which sector? You see, questions are not so difficult and you can answer them. Of course, that is a tertiary sector. The extraction of raw material from the earth's surface, which is which sector, that one? It is also a primary sector concerned with the processing of raw material. Processing. The moment they talk about processing of raw material, automatically that is secondary sector. Okay. Provision of electricity is an example of which sector? Is still secondary sector. The manufacture of textile, footwear, and clothing, which sector is that? Secondary sector. It contributes the least the GDP of South Africa of the economy. That is the primary sector. Okay. So you must be in position to understand these aspects. Okay. So some of you wonder, why is it the primary sector contributes less? You know very well that some of you or most of you look at the primary sector and consider it as a dirty sector. Data sector for dirty people. Dirty, you know, you go to the garden, you come when you're very dirty and so on and so forth. So a few of them go there. And some of you immediately you graduate, you get your degree or your diploma, whatever. You go into the cities to look for a job. You're looking for a job to be employed. You understand? But which sector? No one will go to look for a job in a farm. No one will go to look for a job somewhere they dealing with farming and so on. No, you all want to go and work in offices and so on. You want the tertiary sector. So you find out that the tertiary sector basically employs more people than any other sector. Okay. Now, the primary sector of South Africa contributes 5% of the formal employment. 5%. Look at 50 plus million people, and they say 5% are only the ones that are employed in this sector. That is very few people. And the number is still decreasing. Can you imagine? So very few people are employed in this sector. Very few people are working in that sector. The reason being, I've told you that this sector is considered to be a DT sector because you go, you work in the farm, you look at yourself like as if I'm not educated. So whoever is educated wants to go and work for someone else. Okay, so it provides work for casual laborers and contributes about 2.6% of the GDP for the nation. Due to the aridity of the land, only 13.5 can be used. Can you imagine? Can be used for the production, and only 3% is considered a high potential land. So if you look at this 3%, only 13 is being used. Where's the rest? The rest is less productive because it is very dry. So you find it contributing less. Okay. Under this primary sector, there are very many activities that we're supposed to look at. Take an example. Under this, there is farming, and under farming or agriculture, we know very well that agriculture is the growing of crops, rearing of animal, and poultry. So when you talk about growing of crops, that is basically farming, arable farming. You go grow crops. Then beef farming or animal keeping. Those are animals when you are rearing animals. Take an instance, the animals that are reared here, we have these different provinces are basically rearing cattle. For example, in Popo, basically we have a lot of them in Northwest. There are very many in Free State, KZN, Eastern Cape. All those provinces are basically known for animal rearing. And now when you proceed and look at these other provinces, say Gauteng, say Northern Cape, those are very, very dry areas. Look at Western Cape. They basically don't keep animals, or few of them keep animals. So their contribution is a little bit less. Okay, so South Africa needs to ensure a healthy agricultural industry that contributes to the country's gross domestic product. Okay, you know very well that we say the GDP, we look at the value of goods produced in the country in a particular year. We say that agriculture needs to contribute more, or it needs also to improve its production. Remember, where there's no agriculture, there is no food insecurity. Social welfare is going to be a problem. Jobs will not be there. And also, we need to depend on this sector for the sustainability of the country. So in that case, we see farming practices must be there, not only to protect the long-term productivity of the land, but must also ensure profitable yields and the well-being of farmers and farm workers. You know very well that on those big farms far away, There, where we have one house, a farmstead, you know that it is not safe. People feel that they are not safe to go and work on the farms. So they need this to be improved so that they can improve the welfare of the farmers. In the same line, we know that if there is agriculture and it is well catered for, food won't be a problem. Look at this. Most of the chicken that South Africa enjoy is coming from Brazil. Okay. So if it is coming from Brazil, what does that mean? It simply means that as if you cannot rear chicken here so that you can have chicken. But we know that most of it is coming from those other countries. Okay. Then we proceed and see. Just still on that point of beef farming, this table here is showing the grazing capacity. When you look at Eastern Cape, I want you to look. Long-term grazing capacity available. This is what is available under here, natural fields or natural fields, and this is what is the lowest, the mean, and so on. We find out that in most of these provinces, some of them don't even have. Look at Western Cape. Okay, I want you to look at Gauteng. There's nothing. Do you understand? Less. So their contribution. This is just analysis of the table as based on the statistics of 2013 and 2014. Okay, so what does that mean? It simply means the table shows the area of grazing capacity in South Africa from the high grazing capacity to the low grazing capacity. Western Cape, Northern Cape, Mpumalanga, and Limpopo have the lowest grazing